Assalamualaikum and good morning to the panels. My name is Afia Afifa and I'm here today to present my final year project, which is a research study on screening of exopolysaccharide produced by Lactobacillus acidophilus during cultivation in rice water medium for heavy metal, zinc, cadmium, lead and arsenic quenched in drinking water under supervision of Associate Professor Dr. Khalilah Abdul Khalil. Heavy metal pollution has become a major concern globally and locally, especially when involving drinking water. Development that occur around Malaysia have given huge impact to coastal ecosystem, which is one of the water sources for us. Some of the heavy metals such as zinc is necessary to human body. However, high intake or excess of heavy metals could lead to the toxification. With the presence of EPS from L. acidophilus, hypothesis say that it can degrade heavy metals through its mechanism. Heavy metal contamination has been recognized as a major health risk due to the toxicological manifestation, and this happened basically due to the man-made activity in the industry of metal base. Also, there are several methods in removing heavy metals from contaminated water, such as chemical precipitation and etc. Although these methods are effective, they are usually expensive due to the high requirements. Data obtained was to assess the degradation of heavy metals by L. acidophilus. The finding of this study would be beneficial for wastewater treatment and in the quality assurance for drinking water. The objective of this study was to determine the amount of yield of EPS by L. acidophilus during cultivation using rice water and to remove heavy metals in drinking water by using the strain. Heavy metal pollution caused by either natural causes such as volcanic activity or by anthropogenic activities such as mining and smelting of metals. Humans can be affected by the pollution from various ways, either through ingestion of contaminated food and water, inhalation or skin contact. Contamination of heavy metals could lead to toxification and disease to human beings. These are some of the examples of the effects of heavy metals pollution on human health and also environment. Bioabsorption is a process of degrading heavy metal with involvement of microbial metabolism or intact microbial cell, in which it occurs by the interaction between positively charged metal ions and negatively charged EPS and cell surfaces. The interaction between heavy metal ion and microbe may occur through various mechanisms to turn the heavy metal into less toxic form. Rice, primarily composed of mainly carbohydrate, which is 38.3% of glucose, can be a great source of carbon to mass-produce EPS production by L. acidophilus. This is the overall methods used in this study. EPS from L. acidophilus isolate was extracted and purified. Final heavy metal concentration was analyzed by using ICP-OES. Sample was heated and cooled down before centrifugation. Obtained supernatant was then transferred into 10 ml of 10% trichloroacetic acid and incubated for 3 hours. Sample was then centrifuged again to obtain supernatant, in which then be transferred into cold ethanol. To obtain crude EPS, sample was centrifuged again after incubation of 24 hours. Obtained crude EPS was diluted with 10 ml of distilled water before injected into dialysis tube. The purified EPS was dialyzed at 4 degrees Celsius for every 24 hours for 2 days. Amount of EPS was calculated by using the given formula. Sample were then analyzed by using ICP-OES Optima 2100 TV, and metal removal efficiency was calculated by using the given formula. 0.1 mg/ml of EPS was extracted and purified from L. acidophilus. Table on the left shows the degradation percentages of each selected heavy metals, which is 99.8%, 93.4%, 96.6%, and 96.2% of arsenic, cadmium, lead, and zinc, respectively. Graph on the right side shows the initial and final concentration of selected heavy metals. Initial concentration of all heavy metal was 1 ppm. Final concentration of arsenic was 0.002 ppm, while for cadmium, lead, and zinc was 0.066 ppm, 0.034 ppm, and 0.038 ppm, respectively. Based on the result previously, it shows that rice water able to act as carbon source for L. acidophilus. Rice water could be considered as good crude medium for the production of EPS, as it composed of sugars that are typical substrate to utilize throughout the microbial fermentation for EPS production. EPS from L. acidophilus were able to degrade all heavy metals after 48 hours exposure. Among all the heavy metals, arsenic was the most effectively degraded compared to other metals. It can be suggested that EPS from L. acidophilus prefers arsenic other than heavy metals. The higher the percentage of degradation of heavy metals, the better degradation occur, in which indicate good activity of degradation by EPS. Occurrence of degradation activity shows that L acidophilus are able to use heavy metals as carbon source. As a conclusion, 0.1 mg/ml of EPS from L acidophilus was able to be extracted and purified, and EPS produced by L acidophilus cultivated in rice water medium was able to degrade all heavy metals selected. There are some recommendations and suggestions that can be used in the future studies. Amount of yield of EPS can be determined by using either FTIR or freeze drying technique. FTIR is an easy, simple, and fast technique potentially used for better recognition, clustering EPS structure, and for the characterization of the EPS, but the purpose of freeze drying is to get the EPS in the cotton form where it can be weighed to determine its amount of yield. This technique is good to stabilize and preserve the products. Thank you.